We have seen linear convolution, what all the commands we have used for linear convolution and how to verify manually and MATLAB. Today in this video we are going to see circular convolution. If you understand the linear convolution previous video, it will be easy for you to understand the circular convolution also, right? So what is periodic convolution and or circular convolution? Both are same actually. Both circular convolution or periodic convolution, both are same. So in normal linear convolution, if you convoluted n samples with n2 samples in linear convolution, if you convoluted n samples with n2, we are going to get n1 plus n2 minus 1. So this is linear convolution. We have seen this one in the last class, previous video. If you refer it, you can see what is linear convolution. n1 samples convoluted with n2, you will get n1 plus n2 minus 1 samples. So in circular convolution, in case of circular convolution, if you are convoluted n1 samples with n2, n1 samples with the same n2 samples, we are going to get max n1 comma n2. So this is circular convolution. If you are convoluting 4 samples with 5 samples, maximum values of samples will come, right? So for example, if the n1 samples you are giving 5 and n2 sample as in 6, so what is the maximum sample between these two is maximum sample is n2, which is 6, right? So that number of samples you will get at output of the convolution is maximum. So this is circular convolution, right? Linear convolution is n1 sample convolution of n2, n1 plus n2 minus 1 convolution you will get. In circular convolution, same, n1 convoluted with n2, maximum of n1 and n2. So between this n1 and n2, so what is the maximum number of samples? So that will be the output of the convolution, right? So let us see with that in the program. So it's the same as what we have used for the linear convolution. So new script. So I'm going to type CLC. So CLC, you know that it is used to clear the command window. So same, X is an input. So X equal to input. So 2 input I'm going to give here also. In X equal to input. Enter the input sequence. Right, so this is first input sequence, which is nothing but an n1 samples, and next one is length. So n1 equal to length of this. So for example, if you are giving the input sequence as 1 2 3 4, n1 will be as 4. So that will be calculated. n1 is nothing but a length of input sequence, how much you are giving. So that is the length. And next is small letter n equal to 0, n1 minus 1. So if it is n1 is 4, so 4 minus 1 3, so n equal to from 0 1 2 3, 4 spaces where values will be allotted. Next one is subplot. So subplot I'm going to give. So since we are subplot is the nothing but different figures we are going to see, so since that we are going to use a subplot. So 3 comma 1 comma 1, which means that 3 rows 1 column and first place of the figure. Step n comma x. So I'm going to plot for n comma x. So these are all we have seen in the last class itself. A label. So x label is n, and y label, y axis is nothing but amplitude. And title I'm going to give here is input sequence. Right, so this is the general term which we have seen in last linear convolution, same as here also we are going to follow. So let me give the command line here. So this is circular convolution, giving the command line. And next we have to give for, this is for this program, this few 10 lines is for input sequence, 2 input sequence we are giving, right? So enter the input sequence, and next is nothing but an impulse sequence. So same what we have done for the linear convolution we have to do here also. So x equal to input sequence. So x is input, so this we can give x of n equal to, and here nothing but h of n, right? So this is impulse sequence, and next is nothing but a length of this input sequence we have to identify. This is impulse, right? So impulse sequence, and next is length of this one. So let us take this as an n2 equal to leng, length of this is nothing but an h, right? So we are going to give h, so length of this one. And next one is n1 equal to 0 n2 minus 1, so which is nothing but an, if the length of n2 is 4, so n1 will be 4 minus 1 3, so 0 1 2 3. So I have executed this one in the linear convolution. You can see that one how it will be executed. And next one is subplot. So here subplot is same, 3 rows 1 column, second place, right? So this is thing. And next one is the subplot step is n1 comma h, right? So I'm going to plot for n1, which is nothing but an n1 and h input sequence. And next is as usual x label, y label. Let us take x label as an n and y label is amplitude, and this is impulse sequence, same. And next one we are going to give for circular convolution. So here in the previous video, if you see for linear convolution, in the linear convolution if you see we will be using conv, right? So here if you see, so help convolution. So this is for, this convolution is for linear convolution. To execute in MATLAB we have already have a command like convolution, conv. This is for linear. To execute this command is for linear convolution. So similarly for circular convolution you have conv, right? This C indicates the circular and C convolution. See, so for circular convolution you have, this is one, a comma b comma n. N is nothing but a number of samples, how many samples you are giving. So both input and impulse sequence should be same. So that is very important in circular convolution. So both should be, value sample should be same. So this is how circular convolutions command, which is available already in the MATLAB. So this we are going to use in the MATLAB program. So y equal to, see in this line previously it is linear convolution, we have given here y equal to conv. So since it is a circular convolution we are going to give C convolution. So error is nothing but an x comma h comma 4. So here 4 is nothing but a number of samples, right? So here I am going to give input sequence as 4 and impulse sequence also 4. So if we are giving 4, both the 4 we have to give here 4. So both the input sequence and the impulse sequence, this should be same. So that is very, very important. In this method we can calculate circular convolution by the command line conv, to perform linear convolution it is conv, right? So that we have seen. In linear convolution we have taken x comma h, only this x comma h we have taken. Here we have extra 4. We are giving extra 4 is an input and impulse length. So this 4 indicates that input and impulse length. This should be designed manually. Both input and impulse sequence should be same. So this input sequence and impulse sequence should be same, and this is the length of this one, right? And next one is n2 equal to